What do we get when we toss a coin? Probably head, probably not. Let's try tossing a die now. What number do you think will show up? 1, 2, 3, 4, or 5, or probably 6? You guessed it right. We are talking about probability in today's activity. Experiments like these, in which the outcome may be different from one trial to another, are called random experiments. The set of all possible outcomes of a random experiment is called the sample space. In the experiment of tossing a coin, the sample space has two elements, head and tail. In the experiment of tossing a die, the sample space has 6 elements, the numbers 1, 2, 3, 4, 5, and 6. At times, an outcome will have more than one element. I may toss a die and the outcome may be an odd number. In this case, the set of possible outcomes are 1, 3, and 5. Such a set is called an event. Probability is the chance with which we can expect the event to occur. Theoretically, probability of an event is equal to the number of cases favorable to the event divided by the total number of cases in the sample space. So the probability of an odd number coming up when tossing a die is the number of elements in the event divided by the number of elements in the sample space. In the previous mentioned example, it is equal to 3 divided by 6, that is half, or 0.5. Probability takes values from 0 to 1. In this activity, we will conduct different trials using a deck of playing cards and compute experimental probability, that is, probability based on our observations, and then compare it with theoretical probability. Here are the pack of cards, and as you can see, we can arrange them in 4 sets, namely hearts, spades, diamonds, and clubs. Observe that there are 13 cards in each suit. We put all the cards together and shuffle them. Let me now draw a card from this stack. What is the likelihood, or what is the probability that this card is a heart, or a diamond, or a spade, or a club? Let's now calculate the theoretical probability of getting a heart. The probability of drawing a heart is equal to 13 divided by 52, that is 1 divided by 4, or 0.25. In the same way, the theoretical probability of getting a spade, a diamond, or a club each is equal to 0.25. Let's now calculate the experimental probability for the same. We'll record the outcomes of 15 trials. Before we begin, let's look at how to calculate probability. The probability of getting a heart, or spade, or diamond, or club is given by the number of hearts or spades or diamonds or clubs drawn divided by the number of trials. We'll start trial 1 by drawing a card from the pack. We have here a card of hearts. So the probability of getting a heart is 1 divided by 1, that is equal to 1. There are no spades or diamonds or clubs in this trial. So the probability of getting each of these cards is 0. This is our second trial. Let's draw another card. Here we have our second card with hearts. We've drawn 2 hearts in 2 trials. Hence, the probability is 2 divided by 2, that is equal to 1. Like the earlier trial, there are no spades or diamonds or clubs in this trial. So, the probability of each of these cards is 0. In trial 3, we've drawn a spade. This is the first spade card that we've drawn in 3 trials. So, the probability is 1 divided by 3, that is equal to 0.33. There are no hearts in this trial. So, the probability of hearts, that is, 2 hearts in 3 trials, or 2 divided by 3, that is equal to 0.67. There were no diamonds or clubs in the trial. So, the probability is 0. This is our fourth trial. Let's see what card we draw. Now, we've drawn a diamond card this time. This is our first diamond card in 4 trials. So, the probability is 1 divided by 4, that is equal to 0.25. The probability of hearts and spades, that is 2 hearts in 4 trials, which is equal to 0.5, and 1 spade in 4 trials, which is equal to 0.25. The probability of clubs is 0 as we have not drawn a club card in the last 4 trials. Here goes the 5th trial. At last we have a club. This is the first club in 5 trials. Hence, the probability is equal to 1 divided by 5 or 0.2. The probability of the other cards, that is 2 hearts in 5 trials or 0.4, 1 spade in 5 trials or 0.2, and 1 diamond in 5 trials, which is equal to 0.2. We've gone ahead and conducted the rest of the trials. We've tabulated the experimental probability of each event for the 15 trials. Let's have a look at them. Let's now represent these experimental probability values in a bar graph. The x-axis indicates the event: heart, spade, diamond, and club. The y-axis indicates the probability of drawing out an event: a heart, a spade, a diamond, and a club. Let's plot the theoretical probability value, which is 0.25 for all the events. What do we infer from this graph? We see that the experimental probability is often quite different from theoretical probability when the number of trials is small. You could increase the number of trials and compare the experimental and theoretical probability values. They will be much closer this time.